Now we will see the in-order traversal of a binary search tree. So here with the in-order traversal, in-order struct node star root, because we start it from the root node. So that is why I will write void in-order struct root star root. So in this, first we have to check if root is equals to null. Okay, if root is equals to null, then the in-order traversal is not possible, so it will return. Otherwise, it will traverse it will traverse with the method of in-order traversal. But as we already know, the in-order traversal first it will traverses to the left side of the root. So that is why in order root left. So it will go to the root left and visit the root. Then it will print %d roots key. Okay. So what it will do? It will print the key of this root. Then from traverse the right subtree. Then it will traverse in order root to the right. Then it will print %t root key, that is the right side of the key it will print. So this is how first it will traverse to the root left, then it will print the, that means it will traverse to the right roots, that means left side root, then it will traverse to the right of the root. So then we will write the main main struct node root equals to null. Initially we will take, then int data to be inserted, then character ch. I will take the character ch. Then we will use the do while function to display, do while loop to display various options to select from to decide the input. So first I will write do print select one of the operations. So the operations that we have to select are, one is insert a new node in the binary tree. So printf 2 is what? To display the nodes of the binary tree via which type of traversal, in order traversal. Then I will write the int choice. I will define this. Then that scanf %d and choice. That choice it will be stored at the address of what? Choice. Then switch to choice. So if it will go to case number 1, if the choice value is 1, then it will print enter the value to be inserted, and it will read it by using scanf function, and inside we will write %d and data. So whatever data we enter, it will read it. Then it will insert node root comma data. So what it will do? It will insert the node to the root root and with the value that is data. Then it will be assigned to root. If the case number, if the value we entered is 2, it will go to case number 2 and it will print in order traversal of the binary tree. Then it will call the function in order root. So from root it will traverse the in order traversal. Okay. Then default, if I don't enter any of these two values, by default it will print a wrong entry and it will break and come out of the switch. Then it will print, do you want to continue? So if we have to continue, we have to type y or we have to type n. Then scanf is there, %c and ch we have to write. So to receive this value y or n. So while ch is equals to y or ch is equals to n. So depending upon the value that we enter, it will continue the operation. Okay. So then it will return 0 at the end. This is called as in-order traversal of a binary tree. Now we will see the pre-order traversal. In the pre-order traversal, first the root will be visited, then the the left subtree will be visited and right subtree will be visited at the last. So this is the pre-order tree traversal. So for that I will write hash include stdio.h, hash include stdlib.h. Then I will declare a node by structure of the node by using struct keyword struct node int key struct node star left and struct node star right. So we already know this. Then we will return a new node with the given value. So whatever new node that is there, that will be returned by using a function called as get node, and with that with the value of that node. So for that I will write another key. I will use another keyword, that is struct node star new node. So again the new node, what we have to do, we have to create another new node which is of type what here, struct node. Then we have to allocate memory for that new node. So you use the function malloc size of struct node for this node. Then that memory will be allocated to the new node. Now new node's key will be for new node we have to assign the value. So that is why we will write new node implies key is equals to value. So that value will be assigned to the new node's key. Okay, then the new node left will make it as null and new node right also will make it as null. Then we will return the new node. It will return new node with that value. Now we will insert nodes in the binary search tree. That is struct node star insert node, struct node star root comma int value. So what we are going to do here, we are going to insert a node, insert a value at the root node. Okay. So that is why if the root is equals to null, then we will get node of value will be returned. Otherwise what happens? Otherwise if root implies key is less than value, then it will first visit. That means if the root key is less than the value, then it will visit, it will insert the node at the what here, right side, root's right side. Okay, so that is why insert node root implies right and that value. Okay, that will be the value will inserted at the right side. So that will be assigned to or taken as root implies right. Then another condition is if root key is greater than value, then that value will be inserted at the left of the root. For that we will write the code like this: root implies left equal to what? Insert node root implies left comma value. Then it will return the root. Okay, this is how we insert nodes in the root node. Then we will see how to do the pre-order traversal of the binary search tree. So first we will write void pre-order struct node star root. Okay. So if that means here pre-order traversal will start from what here root. Then if root is equals to null, it will return. Otherwise it will visit the root. So that is why first we will print %, root implies key. So root's key will be printed next. Then it will traverse to the left subtree according to the definition of binary search tree. Then it will apply pre-order root implies left. So it will traverse to the root's left and then the pre-order will be applied there. So then it will go to the left subtree and traverse the nodes there. So once it traverses all the nodes there using this pre-order function, then it will traverse to the right subtree of the root. Then how it will visit right subtree of the root? Again it will call pre-order and with the value, that is root implies right. So it will go to the right side of the root, and again it will call what here, the pre-order function there, and it will visit all the nodes which are at the right side of the root node in the pre-order manner, like this only. Yes, then we will see the main part. Int main. So struct node star root equals to null. Initially, if the root value, we will assign root value as what? Null, and we will take the data. So we will write int data. Then we will take character ch, because we need to switch to particular case. So for that we need ch here. Then I will write do while condition here. So do what we will do here is first print select one of the operations. Okay. So it will print this, then it will print one to insert a new node in the binary tree. So if first option is what? To insert new node of the binary tree. Another print 2 to display the nodes of the binary tree in the pre-order traversal manner. So if I press 2, then it will, what it will do? It will go display all the nodes in the binary tree in pre-order traversal manner. Then we will write int choice, okay, one integer type, that is choice. Then we will use scanf %d and choice. This choice will be read, and then we will write the switch case by giving this choice as input to this. So if I press 1, if I enter 1, then it will go to case number 1 and print enter the value to be inserted. So whatever value that we will enter, that will be read by the scanf, and the value will be stored at the address of the data. Okay, that is how it will happen. Then root equals to insert node root comma data. So it will insert the data to this root, and that then it will be assigned to what? Root, then it will break. So whatever value we have inserted here, that will be assigned to what here? Root. Okay. Now it will break, and if I press 2, then it will go to the case number 2, and it will print pre-order traversal of the binary tree. Then it will apply pre-order of root, because it will start with what? A root. So it will do the pre-order traversal. That means here first it will visit the root, next left subtree, and then right subtree. Like this it will visit all the nodes in the tree. Then if I press any other values other than 1 and 2, it will go to default case and print wrong entry, and it will break there. Then we will write print, do you want to continue? Then we have, if I press Y, it will continue the pre-order traversal. If I press N, it means no, so it will stop the pre-order traversal. So depending upon the value that I enter here, then it will continue the operation. Then we will write while ch is equals to y or ch is equals to n. This is when ch is equals to y and ch is equals to n. So depending on that, the operation will continue or it will stop. Then it will return 0. Then here, then the last type of is post-order traversal. Okay, the another one is what? Post-order traversal. Here the root is visited last in this traversal, in the post-order traversal. Hence the name is called as a post-order traversal. Here left subtree will be traversed first, then the right subtree will be traversed, and at the last the root will be visited. So that is why it is called a post order. So first left subtree, then right subtree, and last this root will be traversed. And here we will write a program for that post order traversal of the binary tree. So we will write hash include stdio.h hash include stdlib.h struct node, and here I will write int key node star left and node star right. Okay, we will define left and right for the node here. Then we will return the new node with a particular given value. So for that we will write the get node function with the int value as the parameter to this function. Then what it will do, it will struct node star new node. Okay, so new node will be generated here, and for that new node we will assign the that means here just I am declaring it. When we assign the memory to that new node, that means the node has been created, then only the node will be created. So that is why I will use mlock function, and I will write function size of struct node, and of that size the memory will, whatever size the node is required, memory size, that will be allocated to that new node. Okay, and then new node key is equals to be the value that I am going to enter here. So that will be taken as the new node key. And new node left I will take null, and new node right also I will take null. Then it will return new node. So this is how we will return what here, the new node. Then we will insert a node in the binary search tree, as we already see in the previous cases. So we will write struct node, insert node, struct node star root int value. So that means from the roots, from root only we will start inserting the, it will traverse through the root and it will insert this value at a particular node, and that is what here the insert node function. But here if root equals to null, then it will return what, get node of value. So it will return that value. Otherwise, if root key is less than value, then what it will do? It will insert the node to the root's right. Okay, that value will be inserted at the root right, and that will be assigned to what, root right. And if root implies key is greater than the value, then it will be assigned to the left of the root. The value will be assigned to the left of the root by using a function called as what, insert node, and that will be assigned to what, a root left. Then it will return a root. Then we will see the post order traversal of this tree, that is binary tree. So void post order struct node star root. Okay, we will write a post order traversal struct node star root. And if the root is equals to null, then it will return. Otherwise, first as per the post order traversal condition, it will traverse to the left subtree first. So post order root implies left means it will go to left side, left subtree of the root and visit all the nodes in that subtree. Then it will traverse to the right subtree. So that is why we have to write post order root implies right. So once we write this, then it will visit all the nodes which are at the right side of the root. Then at the last it will visit what, the root nodes. So that is why print %root implies key. So this is how all the nodes will be visited in the post order manner. Now we will write the main for this. So struct node root equals to null. I will initialize initially, and int data we will define, and character ch we will define. Then we will write the do while statement here to display the various options from the by using different various operations. So do printf select one of the operation. If we select one, it is to insert a new node in the binary tree, and if I select two, it is for to display the nodes of the binary tree in the post order traversal method. Then I will define another variable, that is choice, which is of type int. Then I will write scanf, that choice value will be read and stored at the address of the choice. Then we will write the switch case, where whatever value that I will enter as choice, depending on that, it will go to different cases here. So if I take the choice, if I enter the value 1 as a choice value, then it will go to case number 1 and print, enter the new value to be inserted. Then whatever value you enter, it will be read and stored at the address of the data in the memory. Then we will insert that root node to the root data, that is equals to root. So this is to insert the node in the tree. But if we enter 2, then it will jump to the case number 2 and print post our traversal of the binary tree. Then it will do the post our traversal from the root node. Okay. So that means it will visit left first, right subtree, then root at the end. Okay, if we enter any other value other than 1 and 2, then it will go to default case and print wrong entry, and it will break there. Then if you want to continue, so it will ask, do you want to continue? So we have to type y or n there. Y means yes, n means no. So if we enter y, then that will be read by scanf statement, and that will be stored at the address of ch. So if we entered yes, then it will go again and do the pre or post order traversal. If we enter n, it will stop and return there. So this is about traversal of a binary tree. Now we'll see the threaded binary tree. These are the binary trees with a thread, which are also known as threaded binary trees. Okay, that means these are the trees with the threads. So that is why they are called as threaded binary trees. And here in this threaded binary tree, each node is a threaded binary tree. That means either it contains link to its left child, or either it contains it to the right child. Okay, so that is why it is called as a threaded binary tree. Okay. Mm. Now we will move to the types of different threaded binary tree. There are two types of threaded binary tree. One is one-way threaded binary tree, and another one is two-way threaded binary tree. Now let us see the one-way threaded binary tree. So here thread will point to the right side and to its previous or its parent. It will point to its parent. Here 5 will point to its right side, which is what here 6. If you take 7, it will point to the right side. The right side is what 8 is there. If you take 9, it will point to what here 11. So like that, this is called as one-way threaded binary tree. In only one side, the thread will point. Here, the two-way threaded binary trees. So what happens in two-way binary tree? So if you take this one, so it will point to its previous node, that is 3, and here 5 also will point to its previous one. That is, there is a path from 3 to 1 and again from 1 to 3 there. Here also 3 to 5 and 5 to 3. And from 5 again it will also point to what? To 6. Okay. So the same way you can see here 7. From 7 there is a thread to what? 6, as well as there is a thread to 8. And here if you take 11, 11, from 11 there is a path to 9, and 9 will point toward to 8 as well as to 11. Here 13 will point toward 11. So these kind of nodes, trees or binary trees are called as what? Two-way threaded binary trees. Here I will stop. In the next session. We will discuss remaining parts of the topics of this one, which is data structure.